is 11 o'clock, and we are Little Shop of Physics Live, and we are live. And my name is Brian Jones. And should we do quick introductions?
Probably.
Yeah.
I'm Brenna, everybody.
And?
I'm Maud.
And we're going to switch, because Maud is going to switch, and we have another person we're bringing on.
I'm Nina.
This is Nina. And we are the Little Shop of Physics Live team, accompanied by Patrick and Adam, who are behind the scenes making all the magic happen, and we will show you them at the end of the episode. We have a special show for you today, and this one's called It's About Time. And what is it about? It's about time. But before we get started, I want to note, we have a different time that we're doing our shows. We're going to do them at 10:30, and that's to better connect with people in the school district, to make sure that we stay away from like lunch times and specials times and things like that. People who are in school districts, either the local school district or any school district, we're very much looking to partner with classes. And you'll see today, we have some videos from Ms. Babcock's class. We went out and visited and took some videos out in the cold, snowy day, and we're going to feature those today. And every week, we want to feature a class. So if your class would like to be part of Little Shop of Physics Live, get in touch with us and let's brainstorm topic and think about how we can involve you. We're really, really excited to do more of that going forward. And I think without further ado, we're ready to get started. We're talking about time today. It's about time. Here's my question for you. How do you define time? I want you to give me a definition. And go ahead and put it in the chat. What is time? What is time? Let's see what folks are saying. Somebody said hello, which is cool.
Hey man, whatever their definition wants
Somebody
to be.
says time. Ooh, clock. That's a good one. Clocks measure time. So that's definitely related. Someone else wrote mod, M-O-D, which we're loving. Someone said
time,
a measurement.
Indeed.
That's good.
Time.
Measurement. You can measure time with clocks. That's for sure. But you know what's happening in the chat? Someone wrote a question mark. That's it. Like, we're not getting a lot. And I think the most impressive answer I got was the question mark. Honest to goodness, you ask me to define time? I have trouble defining it. I know what it is. And so today we're just going to play with time. And what we're going to do is this. You have a natural scale of time that your body works on. And sometimes things are super amazing, and you can't necessarily see what's happening until you slow things down. I think Brenna has got an example for us.
I do. So here I have the classic pull the tablecloth out from under a bunch of dishes trick. And when I do this, it's so fast that you can't actually see what's happening. So if I stand up and I
oh my gosh,
quick,
pull the tablecloth out from underneath the glasses. But if we want to know, how close was Brenna to disaster on that?
How close was I?
I think she was perfect.
We got an instant replay
Thanks,
here. Here's our instant replay. Put some glasses on there and yank it and check it out. Oh, they definitely moved and they definitely sloshed. And that one glass got a little on the close side. You got to be really, really quick to make this happen. And then when we slow it down, you can see the cloth came out from underneath, but there definitely was some motion, definitely was some sloshing to happen here. And slowing down the time made it so you can see that. And there's a lot of amazing things that are happening quicker than your eye can see, but you probably have a phone or a camera that can make slow motion videos. So we want you to think about what kind of things would look cool if we slowed them down. And we did just that with Ms. Babcock's class. We went out to McGraw Elementary and we went out on the playground where it was cold and snowy and asked people to come up with interesting ideas about what would look cool if we filmed it in slow motion. And let's see what we got. This was an awesome, awesome day. Bouncing a ball, and look at when it hits the ground. Bouncing balloons. Water balloons bounce. Who knew? Punching water balloons is kind of awesome. And you can watch it kind of like bulge out on the other side. And other folks, go ahead and weigh in with what you're seeing. Oh my gosh, look at that. Boom.
I really like the noise that all of these make.
The noise is awesome.
Yes.
Popping the balloon, and that water just stays in kind of a spherical shape just for a second, which is kind of cool. And that was a brave person who was willing to get wet on such a day. And then we rolled the water balloons down the hill, and they kind of like spread out into a wheel shape. Oh, and then breaking sticks. And when you do that, you frequently get this third piece in the middle that pops out. And we were interested in that. And you can kind of see what's happening in this slow motion. And we also did some, wait a minute. That looks a little unusual. That looks like it's going backwards there. Oh my gosh, that's a little foreshadowing for what comes next. All right, and there's tossing slinkies. The tossing the slinky is kind of awesome. And now dropping slinkies. And when you drop a slinky, it does kind of a very cool thing. The top falls long before the bottom does. And that's something that's worth capturing in slow motion, to just see the physics of what's happening there. And if you bounce a slinky, it actually sends little waves. What's that?
You can see a wave.
What? Waves? We love waves. We should do a show on waves. Oh, wait, we did. But we could do another.
We could.
And I see a lot of snow going through here, too. This was a chilly, chilly day. Brave folks. Ooh, and folks are putting things in the chat saying what would look cool. And we want you to try other kind of like awesome things. What would look good if you did it in slow motion?
Awesome.
Now, we did some work here in the Little Shop of Physics, and we thought, what are some things that would look cool if we did them in slow motion? And I think other people did this. We have some videos that we made here in the shop, and we're going to pull some of those up. And these are some things that you can try because they're kind of awesome. Creepy noises. That's cool. Ooh. Whoops.
Whoops.
We got McGraw back again. That was awesome. That was awesome. But let's see some of our local CSU people. Vibrating humans. This looks cool. Whoa. And who did this one?
Oh, I did. That's my arm right there.
And tell me what you're doing, Maud. What are we seeing?
So I used one of those like little back massager things that you can get you buy at the store, and I just used it on my arm, and you're seeing the vibration of that massager through my arm.
Oh my gosh, and here's Casey vibrating her.
She looks like she's going to go to sleep.
She does. But she's just doing a little raspberry, and that was kind of an awesome one. And we did some breaking of spaghetti too, which was comparable to the breaking of the sticks. And this is something that would be fun to try. Oh, I see someone, Kai is doing the thing there with the lips. Yeah, you should videotape that in slow motion. When you break a piece of spaghetti, it always breaks in 3 pieces. And this third piece comes flying out. And it looks like it gets a bit of a spin too, which is kind of awesome. And you always get that third piece. And we were trying to film it in slow motion to see if we could figure out exactly why. And that would be another kind of like interesting piece to look at. What is happening when I'm breaking spaghetti? And then finally we figured we're not content with just breaking spaghetti. We wanted to break some glass objects. And this is one I would suggest that you don't try. It took us a lot of time to do this safely. But we did breaking objects when we drop them in slow motion. And I want you to look and listen.
Maud, which one was the coolest since you did this one?
I think that one right there, that long neck flask going down, that was the coolest for me.
I like that one too, the Erlenmeyer flask.
Oh, yeah.
And the sheet of glass was kind of awesome.
The really skinny or short tubes didn't really do too much, which I think is pretty cool compared to how much those beakers and flasks broke.
Yeah.
And if someone wants to see this, we're going to post this on our webpage so you can see you can take a look at this again. You can do it backward and forward. Ooh, I have another definition of time. Time is time. That's kind of a good definition. It's a little tautological, but that's okay. Someone wrote lighting a fire. Oh, that would be cool in slow motion. So I want you folks to try some things yourself and see what looks cool in slow motion. If you find something awesome, share it with us. Well, we've looked at things which look good or interesting if you film them so that you can see the stuff which is happening really, really fast. But another thing we want to think about is the direction of time, okay? We made some videos with the kids at McGraw, and we asked them to try different things. And could we tell if the video is going forwards or going backwards? So go ahead. We're going to play a series of clips and put it in the chat. Which one's going forward and which ones are going backwards. How about this? Forward or backward? What do you think?
Looks forward to me.
I can't even
How
tell.
about this one?
Yeah.
Time isn't real.
It isn't.
Jumping, man. I don't know. I'm having trouble telling. Oh, this one.
That looks kind of funky.
That does look a little backwardy to me.
Or that kid's just really talented. One or the other.
Let's assume really talented. Here's skipping.
I feel like I would have to be there to understand.
And the swinging. Man, that looks...
I don't know.
I don't know. I don't know if that's forward or backward.
What's everybody thinking?
Nobody's saying anything. People are just like, they're not sure. Someone just get, what, I think I know about that one. That does not look, someone said forward, but this looks a little...
Suspicious.
That looks a little suspicious. Rainbow says that is backwards.
I wish we could do that.
That would make going to the playground a lot more fun.
Be awesome.
Now here's the totally crazy thing. All of the clips were played backwards. Whoa. So that is crazy. So we want you to go ahead and check out, we'll post that video. Take a look at it. And the interesting thing is, it's really hard to tell which ones are forward and which ones are backward, particularly when you have motion that repeats. If you have motion which is cyclical and it goes over and over again, like on the swings, or jumping, or walking because your legs are moving, and you're doing the same thing over and over again. When you get those cycles, it's really hard to tell. It's just a cycle that repeats, and the physics of it is pretty much the same forward as backward, and that's a really interesting physics principle. Since we've gotten to the idea that things, you can have a certain natural time for things. Things have a certain cycle. They repeat every so often. Clocks do that. You have a tick of a clock, and it repeats. We're going to look at things that have a certain natural time, and they have a certain natural cycle that repeats, and we want to think about the idea of matching the different times for different things. So I got a bunch of metronomes here, and this is kind of an awesome thing. They all have a certain frequency that they like to go at, but I'm going to start them.
Brian, are we going to look at what we did for forwards and backwards?
Did I skip that?
Yes!
Sorry.
Come on.
I'm sorry.
I sat and got up from a chair like 16 times for this.
I'm sorry,
Brian,
yes.
you're getting ahead of
Chairs
yourself.
are important.
I tell you. So call me out on that stuff. Sorry, which clip is forward and backward? The CSU ones. And actually, can we start that one again? Because I'm going to launch a poll. And we're going to show two clips. And I want you to tell me which clip is being played forward and which one is being played backward. We're going to play clip number 1 and clip number 2. Which is forward, which is backwards? Let's do it.
I'm curious to see what people say.
I feel like if I answer, it's cheating because I'm the person in
Yeah,
on it.
might be.
Okay, this is clip number 1. There's Maud talking and Maud sitting and standing. And here's a bunch of Little Shop of Physics people dancing. Here's clip number 2. Same things. Maud is talking. Maud is sitting and standing. One of these clips is being played forward. One of them is being played backward. Which one is being played forward? 1 or 2? We're going to pause, give people a chance to weigh in.
Maud kind of looks like a sim when she's sitting up.
Oh.
Man, and it is pretty evenly split.
Huh.
I had
It
to
is
make
like
sure that mechanism was the
About
same.
half of the people are saying clip number 1 is played forward, and about half of the people are saying clip number 2 is played forward. Should we play it with the sound on so we can see?
I think so.
Let's do it with the sound, and then you should be able to tell.
We watched this before the show, and I don't even
I don't remember which one is which either.
Which one's forwards, which one's
Oh
backwards?
yeah, and I think with the sound on now we can tell. We can tell. All right, and someone's saying, I knew it. I knew it. But it's really tricky to tell just visually. The sound is a really, really good clip, but visually a little tricky. So that's something that folks can try. Now, cyclical things. and getting in synchrony. Apologies for jumping ahead. You guys just got to call me out on that stuff. So here's a bunch of metronomes. What I'm going to do is I'm going to get them all started, and they're all out of sync with each other. They're all vibrating at the same frequency, and if I just let them go, what will happen is they're on a rolling board, and that couples them a little bit.
That one, it's not wanting to go. Oh,
less chaos.
Oh,
Getting
the last
there, getting
one. Sync.
Oh, that first one just does not want to bend to the will of the others.
Oh, there he
go.
goes.
And they're all synced up.
Oh, cool.
All in sync. And they will do that naturally because they're on this board that can roll. And so things... Oh yeah, I got a little dancing going on. Perfect, perfect. So things have a natural frequency that they like to go at. And if you drive them at the frequency they like to go at, you get some interesting effects. Maud has got an example to show us. Maud, what do you got?
So here I've got a fish tank. If we all remember the OG Franklin, he is hanging out in here. And we've got a bunch of blue water. And if I just go really, really fast, nothing's happening. Franklin has turned over now. And if I just don't do anything, it's just sloshing back and forth. But if I kind of match the frequency that the water wants to be at, it's a really easy time. And it's just going with me here. And you got some standing waves, which is really cool.
Maud, is this kind of like when you're in the bathtub and you slosh around?
Yeah, we actually got this idea way back when Emma brought it up, and you can make like a tsunami in your bathwater by pushing against it, as much as parents will love me for telling people about that one. I'm just going to move this here. And then this works the same way in something much closer to home for some of you, is, especially now in the winter weather, is like hot chocolate. And so, I'm just going to fill up my mugs.
And it looks like I can already see the liquid sloshing.
Yeah, even when you pour it in there, it's moving back and forth.
Oh, yeah. Look at that go.
And you can see the frequency. There's a certain frequency that it likes to slosh at. And Maud, if you oscillate the tray at the frequency it likes to slosh at, go ahead and move the tray back and forth. And you can see I'm getting some sloshing. Can you make them slosh a lot?
If we really want hot chocolate all over the place.
Frequency?
Absolutely.
Oh, yeah. And now we're getting lots of sloshing. And this can happen if you're walking with a cup of cocoa. You could slosh, and we don't want to be spilling cocoa.
Absolutely not. I want my cocoa in my stomach, not on the floor. So there are two ways that you can actually help with that. So one is I've got a bunch of marshmallows, and the other is, my personal favorite, is a can of whipped cream.
Which, note to all you folks, Brian doesn't like whipped cream.
You don't like whipped cream on my cocoa.
Because he's crazy, all right?
But that's all right.
Delicious. But now, watch what happens when I...
Oh, whoa!
The control is going all over the place.
It's going everywhere. And the one with the foam and the one with the marshmallows, those are staying put.
Because that foam kind of just stabilizes it. The whipped cream isn't moving at all. Marshmallows are moving a little bit, but much less.
So if you ask for whipped cream on your hot chocolate, it's not because you want a treat, it's because you're trying to protect the carpet, is what I'm seeing.
Yeah, you're doing some cool physics.
Awesome. That is an awesome, awesome thing. And that, with cups, when you walk with cups, sometimes they will slosh. You might have noticed this before, and Brenna's got a little thing to show us about this.
I do. So here I have my walking simulator, and I have a bunch of different vessels. I'm going to pour water into all of them. I colored the water to make it easier to see.
Oh, and I can see that's got a certain sloshing frequency already. I can see it sloshing back and forth.
And this last container, I just spilled it everywhere, but
that's okay.
This last container, have you ever tried to carry your dog's water bowl anywhere? It's nearly impossible, and it's because the frequency that the water in this bowl likes to resonate at is pretty similar to your walking. So when you're walking, it just kind of amplifies it, and it ends up going everywhere. And we can see that just by me slightly moving this thing.
Sloshing like...
And you can see the wider the container, the worse it is.
Oh my gosh.
This one right here
The glass,
pretty
I don't
mellow.
think you spilled any out of that,
Yeah,
did you?
it's pretty mellow. And of course this one, they're trapped in there. But you can see this one, my drink is gone.
Oh, that is an awesome, awesome thing. So the water has a certain frequency it likes to slosh at, and if you slosh it back and forth at this frequency it likes to slosh, you get a lot of motion.
Yes, you do.
Speaking of containers with water in them, I think you got a water balloon. That's a container with water in it.
I do, and I'm trying to dry up my area here. But here I have a water balloon, and if I bounce it at a certain frequency, the water comes up to meet my hands, I push down, and it bounces. And we got a pretty cool slow motion video of this to show you guys exactly what's happening.
And the key is you want to match the frequency of your pushing with the frequency that the balloon likes to bounce at. If you match those two, you can actually dribble that thing.
You can, and you can get it pretty far off the ground. It's kind of awesome. And this kind of relates to what we were talking about before, where when things oscillate, you can't necessarily tell which direction they're going. But you can also do this just in your own house. You can videotape yourself walking. So our arms work the same way. So if you get up and you just walk with me, your arms like to sway.
Just let them swing, Brenda. Don't bend your elbows. Just let them swing.
Fine.
Let them swing.
Your arms just kind of swing back and forth at a certain frequency. Now I want you to try and swing them twice as fast. It doesn't really work.
When people are doing it, I can see them doing it.
Yeah, if you want to go faster, like when you're running, what do? You put your arms up and you can swing them a lot faster. And I want you guys to try walking and making your arms go out of sync with your walking. It's nearly impossible. It's kind of awesome.
I want to come back to that for just a minute, because it looks like when your arms are swinging, they're looking like pendulums to me. So this is like a pendulum motion on your body. It looks like the length of your arms and your legs is about the same. So I'm thinking the frequencies of those things should be about the same. Now other things oscillate, and then Nina has got a really kind of interesting example of some oscillation, and Maud has left us. Maud is off.
I'm the new Maud for right now.
She's Maud 3.
So I have a speaker sitting with a piece of plastic laying on top of it. And it turns out that, like everything, sand has a frequency that it likes to vibrate at. So what will happen is, if I turn this speaker on, maybe it's not.
That's just a regular loudspeaker, right? And you just put like a plastic sheet on top of it.
Yep.
So the speaker is going to be vibrating, and the vibration of the speaker is going to make that sheet of plastic vibrate.
Oh, here we go. Turns out the speaker.
Oh, lost the connection?
We lost the connection.
That's okay.
There we go. I hear it now.
There we go.
Now it's vibrating.
All right.
And you're going to tune it until it's like at its loudest, or have you already done that?
Let's turn it louder. And now it's at a place that this sand will like to vibrate.
I think the plate is vibrating. What's happening is the sand is going to collect in the places where the plate isn't vibrating. Oh my gosh, look.
Oh, that's kind of cool.
And if you can see, it's creating a pattern.
Looks like a bunch of dancing fleas.
It does. It does. And you can see there's certain places where the plate is vibrating, where they're moving, and certain places where the plate's not vibrating, and so the sand is not moving.
All right.
That's an awesome thing. Now next, I'm going to show you a little demonstration, and this is kind of an awesome thing that I learned about dogs and their breathing. So right here, I've got this tube, which has lots of air in it. It's a long, 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 long tube. And on this end, there's a kind of a rubber diaphragm. I'm going to flip it around so that that's tipped more towards you. Okay. So rubber diaphragm. And if I push it in, that pushes air out the tube. But this thing's stretched and it pulls the air back in. And you can watch it oscillate. This oscillates. And it turns out when dogs pant, their diaphragm is kind of like moving up and down like this. It's a little bit stretchy. It's pulling air in and out. So if you're a dog and you want to pant, what you do is just give it a little shove every cycle. It's like Brenna bouncing the water balloon. You just give it a little shove, and you don't have to like work it all the time. It's just a little shove every cycle. It's like Brenna bouncing the water balloon, like pushing someone on a swing. And dogs use this to make them more efficient, and the frequency that they pant at is equal to the frequency that they gallop at. So I have a little video of my dog Milo. And when Milo is coming in, he's galloping, and every time he comes down, he goes, oh. That makes him breathe out. Breathe in, oh, breathe out. And so he's actually driving his panting with his galloping. And that makes him more efficient, just makes it that much easier for him to take those deep breaths that he needs to when he's working hard fetching a ball, which is something he loves to pieces. Now, one last thing we're going to talk about with time. You would think when you mix things together, they're not necessarily going to unmix. If I had a video of like mixing something, you would think you would be able to tell if it's forward and backward. But there's cases where it's a little bit more complicated than that. I've got some sand, and inside this container with sand, there's a rock. And if I shake it back and forth like this, I can actually make the rock come to the surface. So it was buried. I can bury it again. And if I want to bring it to the surface, what I can do is I shake it, and then the rock is going to surface. And this actually happens in nature. If you have areas where the ground freezes and thaws, you can have rocks that are buried underneath the surface, and then they're going to like rise to the surface. And so I can actually get a situation of having unmixing. And you've seen this before. And we had a sample of the cocoa that Maud was using, and the cocoa has marshmallows in it. And you might have noticed if you get the cocoa from the store, all the marshmallows are on the top. If I take them and I bury them, so I'm going to take these marshmallows, bury them underneath the cocoa. When I shake it, they unmix. And actually getting them to stay mixed is a little bit of a trick. You've seen this before. And also, if you have cereal which has marshmallows in it, which probably you shouldn't be eating because it's too sweet, but still.
Lucky Charms, you can get all the marshmallows off the top.
Every kid's dream.
And Nina has an even cooler demonstration to illustrate
This is pretty
effect.
cool. This one even amazed me. So I have water that is dyed blue and rubbing alcohol that is dyed pink. And so I'm going to mix them together in this water bottle.
How'd you dye the alcohol pink, Nina?
I actually had to squeeze a highlighter. I don't recommend. It was very, very messy. My hands were pink for a whole day.
Well, it makes that kind of blue color, which is kind of awesome. So you just took those two liquids and you mixed those two liquids.
Yep, and as you can see, they've created purple.
Awesome. Well, that's
So
pretty
you
well
would think,
mixed.
yeah, so you would think we wouldn't be able to unmix these, right? They're completely mixed together.
It looks pretty mixed.
All right, well, I have something pretty amazing. This is salt that I'm pouring in.
Man, you're putting in a lot of salt.
You need a lot of salt because the water has to completely saturate the salt. And now I'm going to give it a really good shake. All right. Let's see.
Oh my gosh, I see something happening there. It looks like it's clearing up at the top a little bit.
Little bit.
You can see there's slightly more blue. It
Oh, it's
takes
blue
just
at
a
the
little bit
bottom.
of time.
Oh, that's cool.
It's definitely, the water is coming out at the bottom. Oh my gosh. Check
Where's
it out.
the
And so
alcohol?
that is actually the salt is making the water come out.
Yep. They're slowly separating. It turns out that salt water and alcohol do not mix. So we turned regular water into salt water.
And let's just let that keep going, and I'll talk about what we're going to do next. So when we're going to watch this thing continue to separate, am I getting some pink up at the top? Yeah, it is getting pinker at the top for sure. And the two layers that I see are fully separating. So it looked like it was mixed, but you're unmixing it. You're unmixing it by adding salt. And what's happening at an atomic level, there's little forces between the water molecules and the ions from the salt, et cetera, et cetera. And this is an example of invisible forces at work at an atomic level. And invisible forces is the next show that we're going to do. Next week, we'll be live at 10:30. And teachers, if you want us to work with your class, get in touch with us. We would love to join you. I want to say thanks to Nina. Thanks to Brenna.
Bye, everybody.
Bye,
And
everyone. Thanks for tuning in.
To Adam and Patrick behind the scenes, our tech crew back here making everything go. There is Adam over at the computer and Patrick at the camera. Thank you all so much. And we will see you next week at 10:30 on Fridays on Photoshop and Physics Live.